Hi, welcome back to my class in plane trigonometry. Today we will take up the 6 basic trigonometric functions of the acute angles of right triangle. Of you who missed the lessons in plane trigonometry before, please search for my videos, Art Teaches Trigonometry. Consider the following right triangle. A right triangle is a plane triangle that contains a right angle. And the right angle in a right triangle is indicated by a square. I will put the angle C as the right angle. And the sides opposite the angles or the vertices we denote by small letters. So opposite angle A is small a. This is the side through the vertices B and C of this right triangle. And the side opposite angle B or vertex C is this side through the vertices A and C. We denote this by small b. And finally, the side opposite the right angle, the angle at C, we denote by small c. We said before that a triangle has 6 parts. These are the 3 angles denoted by capital letters A, B, C. And the 3 sides denoted by small letters A, B, C. And we identify the specific sides of a triangle, of a right triangle. We said that the side opposite the right angle, the small letter C is the hypotenuse. And the 2 other sides of the right triangle are referred to as the legs of the right triangle. For this right triangle ACB, the hypotenuse is small c, the side C, the side through the vertices A and B. The hypotenuse is the side opposite the right angle C. And the 2 other sides of this right triangle, denoted by small a and small b, are called the legs of this right triangle. Now, with reference to an acute angle of this right triangle, we further identify the sides of a right triangle with reference to an acute angle. We said also last time that the sum of the 3 angles of a right triangle is 180 degrees. Since the right angle C is 90 degrees, then A plus B must be equal to 90 degrees, which means that A and B are complementary angles, and these angles A and B are acute angles. A or B cannot be 90 degrees because the right angle is already at C. Therefore, this angle A and angle B are acute angles. We consider angle A with reference to angle A. We say that this side B, the side through the vertices A and C, is the adjacent side. Adjacent side equals B. With reference to the acute angle A of this right triangle, this side B, small letter b, through the vertices A and C is called the adjacent side. It is called the adjacent side because this side small b is adjacent to angle A. It is the side of the right triangle which makes the angle, the acute angle A with the hypotenuse. Again, the small b, the side through the vertices A and C, is called the adjacent side because firstly, it is adjacent to angle A, and secondly, it is the side of this right triangle that forms this acute angle A with the hypotenuse. And the small letter A, the side through the vertices B and C, is called the opposite side. Small a is the opposite side. Small a is called the opposite side first because it is opposite the acute angle A that we considered. And this small a is not connected with angle A. The side small a is not connected to angle A. And the hypotenuse is still small c. Hypotenuse is still the small c. Again, with reference to the acute angle A, the small b, the side through the vertices A and C, is called the adjacent side. It is the side that forms the acute angle A with the hypotenuse. And the side small b is adjacent to angle A. The side small a is the side opposite angle A. This side small a is not connected with angle A, but it is opposite angle A. And the hypotenuse remains the same, the side small c. It is the side opposite angle C. Now we consider angle B, the acute angle B, and we identify the adjacent side and the opposite side with reference to angle B. The adjacent side now is small a. The side through the vertices B and C. Because this is the side small a that forms this acute angle B with the hypotenuse. Adjacent side is A. Now the side opposite angle B is now small b. Small b is called the opposite side. And this side B through the vertices A and C is not connected with angle B, but small b is opposite angle B. And the hypotenuse is still C. Hence, regardless of the acute angle that you consider, the hypotenuse remains small c. The side is small c. It is the side of the right triangle, opposite the right angle. It's only the adjacent and the opposite sides that change depending on which acute angle that you consider. Now, if you consider this acute angle A or this acute angle B, you can write the 6 trigonometric functions of each acute angle of a right triangle. And these 6 trigonometric functions are the 6 basic trigonometric functions. The first of the 6 basic trigonometric functions is the sine function. Sine. If you simply write sin, you have to specify the angle, because simply writing it this way has no meaning. You have to write an acute angle, either A or B. I will use angle A. So one of the 6 basic trigonometric function of acute angle A is sine of A. You read sine of A or sine A. The second of the 6 basic trigonometric function is cosine. Or we simply write cosine of an acute angle. We are considering angle A. You read cosine of A or cosine A. And the third is the tangent. Tangent of an acute angle. If we are considering the acute angle A, we simply write tan A, but is read as tangent of A or tangent A. The next 3 of the 6 basic trigonometric functions are reciprocals of the first 3. The reciprocal of sine is known as cosecant or cosecant. Using the acute angle A, we write CSC. Cosecant of A or cosecant. And the reciprocal of cosine is known as the secant or secant. For the acute angle A, we write SEC. We read secant of A or secant A. And the last is the reciprocal of tangent, and it's called cotangent. Or COTA. Cotangent of A or simply cotangent A. Now the sine of A, cosine of A, the values of these 6 trigonometric functions of the acute angle A are equal to the ratios. The ratios of 2 sides of this right triangle. A ratio is a fraction, hence each fraction has a numerator and denominator. And this numerator and denominator are sides of this right triangle. For example, the value of sine A is equal to the ratio of 2 sides of this right triangle. And if we have 3 sides of a right triangle, there are 6 possible ratios that can be formed. As I said, to form a ratio, we need 2 sides of a triangle. Or considering the 3 sides of a triangle, there are 6 possible ratios that can be formed using 2 sides of a triangle. For the first 3 ratios, we have to take 2 sides at a time from 3 of the sides of a right triangle. So from these 3, we have to take 2 sides at a time to form a ratio. Because a ratio is a fraction with numerator and denominator. And the numerator and denominator of this ratio are the sides of this triangle. Now from algebra or from basic statistics, if you take 2 sides from 3, then you can get the number of ratios that can be formed, or the number of ratios that can be formed is equal to combination of three sides taken two at a time. By formula, this is equal to 3 factorial divide by 2 factorial multiply by 3 minus 2, 1 factorial. Or 3 factorial is 3 multiplied by 2 multiplied by 1. And 2 factorial by definition of factorial is 2 multiplied by 1. And 1 factorial is 1. And cancel what can be cancelled. We are left with 3 divided by 1 is 3. Hence, if we have 3 sides A, B, C, and we need 2 sides at a time to form a ratio, the number of possible ratios that can be formed using 2 by selecting 2 sides out of 3 sides is 3 ratios. With reference to the acute angle A, one of the 3 ratios that can be formed is the ratio of A, which is opposite angle A, to the hypotenuse is small c. Again, with reference to A, the sine of angle A is the ratio of the opposite to the hypotenuse. The ratio of the opposite one of the first 3 ratios that can be formed is the ratio of this opposite side with reference to acute angle A, opposite side divided by the hypotenuse, or opposite is the side is small a, hypotenuse is the side is small c. This ratio is the value of the sine of the acute angle A. Another ratio that can be formed with reference to the acute angle A is the ratio of the adjacent side B, small b, to the hypotenuse small c. And that ratio is the value of cosine of angle A. Cosine of angle A is the ratio of the adjacent to the hypotenuse. Again, the cosine of the acute angle A is the ratio of the 2 sides, the side adjacent to angle A, and the hypotenuse of the right triangle. In this right triangle, the adjacent side, the side adjacent to angle A is small b, over the hypotenuse. The hypotenuse is small c. And the last of the 3 ratios that can be formed by taking any 2 sides from the 3 sides of a right triangle is the ratio of small a with reference to angle A. Small a is the opposite side, and small b with reference to angle A. Small b is the side adjacent to angle A. So the third and last of these 3 ratios is the ratio of the opposite to the adjacent. Opposite to the adjacent side. And again, using this right triangle, we denote the opposite side, the side opposite angle A by small a. And the adjacent side, the side adjacent to angle A by small b. So these are the three ratios that can be formed using two sides of a right triangle with reference to the acute angle A. Again, sine is defined as the sine of an acute angle is defined as the ratio of the side opposite the acute angle and the hypotenuse. The cosine of an acute angle A is defined as the ratio of the side adjacent to the acute angle A to the hypotenuse. And tangent of the acute angle A is the ratio of the side opposite the acute angle A to the side adjacent to acute angle A. Now for some to easily remember this, the sine of A is written as so. Where S is for sine, and sine is the ratio of the opposite to the hypotenuse. And cosine of A, defined as the ratio of the adjacent to the hypotenuse, is written as K. Where C is the cosine of the acute angle, defined as the ratio of the adjacent side to the hypotenuse. And tangent of A, defined as the ratio of the opposite to the adjacent, is written as TOA. And this is what some people use to remember the first three of the basic trigonometric functions of an acute angle using SO, Ka, TOA. Where in SO, S is for sine, defined as the ratio of the opposite to the hypotenuse. Ka is the cosine, defined as the ratio of the adjacent to the hypotenuse. And TOA is the tangent, defined as the ratio of the opposite to the adjacent. Now, we said earlier that there are six ratios that can be formed using these three sides of a right triangle. And we have already listed down the first three ratios of the six possible ratios. And these first three ratios define the first three trigonometric functions of an acute angle. The values of the last three trigonometric functions are the reciprocal of these first three ratios. As I said earlier, cosecant of A is the reciprocal of sine A. And sine A equals opposite over hypotenuse. And the reciprocal of this from algebra is hypotenuse over opposite. And that is the value of cosecant of A. Hypotenuse over opposite. And the ratio hypotenuse over opposite is equal to the ratio of A over C. And the ratio of A over C is C over A. As I said earlier, cosecant is the reciprocal of cosine. And the cosine of the acute angle A is the ratio of the adjacent to the hypotenuse. And the ratio of this adjacent to the reciprocal of this ratio adjacent to the hypotenuse is hypotenuse over adjacent. Hypotenuse over adjacent. The ratio of hypotenuse to the adjacent is equal to the reciprocal of B over C. Or the hypotenuse is C. And adjacent to A is B. This is C over B. And cotangent is the reciprocal of the tangent function, defined as the ratio of opposite to the adjacent. You get the reciprocal of opposite to the adjacent, and we get adjacent over opposite. Adjacent over opposite. And adjacent to angle A is the side small b. And opposite angle A is the side small a. These are the 6 trigonometric functions of the acute angle A. The values of the 6 trigonometric functions of the acute angle B are also equal to the ratios of two sides of this right triangle. And we will list them now. We now write the values of the 6 trigonometric functions of the acute angle B using our right triangle. If we want the 6 basic trigonometric functions of angle B, you have to first identify the 3 sides of the right triangle with reference to the acute angle B. And with reference to the acute angle B, the side adjacent to angle B is small a, the side through the vertices B and C. This is the adjacent side. It is the side of the right triangle that forms the acute angle B with the hypotenuse. And the side opposite angle, the acute angle B of this right triangle is the small letter b, the side through the vertices A and C. And this is the opposite side. And you can see this side, small b, is not connected to the acute angle B. And the hypotenuse is still small c. It is the side opposite the right angle of the right triangle. Again, regardless of which acute angle you are considering, the hypotenuse remains the same. It is the side opposite the right angle. It is only the adjacent and the opposite sides that will change. For the 6 trigonometric functions of the acute angle B, the adjacent side is small a, opposite side is small b, hypotenuse is small c. The side of B is defined as the ratio of the opposite side, the side opposite angle B, to the hypotenuse, or the value of sine of acute angle B equals opposite side divided by hypotenuse. And from this right triangle, the side opposite angle B is small b, divided by the hypotenuse is small c. Number 2, cosine of angle B is defined as the ratio of the side adjacent to angle B. Divide by hypotenuse. And from this right triangle, Adjacent to the acute angle B is small a. And the hypotenuse is small c. And the tangent of the acute angle B is defined as the ratio of the opposite side, small b, opposite tangent of B is the ratio of the opposite to the adjacent. And opposite side, opposite the acute angle B is small b. Divide by the adjacent side, adjacent to angle B is small a. You only need to remember the first three of the 6 basic trigonometric functions, because the values of the last 3 trigonometric functions of an acute angle are the reciprocals of the values of the first 3 trigonometric functions. For cosecant of B is the reciprocal of the sine function, sine of angle B, whose value is opposite over hypotenuse. And the reciprocal is hypotenuse over opposite. And you can get this value by taking the reciprocal of B over C, which is C over B. Or from the diagram, hypotenuse is C, and the opposite side, the side opposite the acute angle B, is small b. 5. The secant of angle B is the reciprocal of the cosine function, whose value is the ratio of the adjacent to the hypotenuse. Its reciprocal is hypotenuse over adjacent. Hypotenuse over adjacent. And this is equal to reciprocal of reciprocal of A over C, which is C over A. Or from the diagram, the hypotenuse is C, and the side adjacent to the acute angle B is small a. And lastly, cotangent of the acute angle B is the ratio or the reciprocal of tangent B, whose value is opposite over adjacent, and its reciprocal is adjacent over opposite. So cotangent of B is adjacent over opposite, and it is equal to the reciprocal of B over A, which is A over B. And you can check from our diagram, the side adjacent to acute angle B is A, and the side opposite the acute angle B is small b. These are the 6 trigonometric functions of the second acute angle B of this right triangle. We take another example. Find the values of the other trigonometric functions of theta if cosecant of theta equals 5 over 3. We know that cosecant is the reciprocal of sine, and sine is equal to opposite over hypotenuse. Thus, the reciprocal of opposite over hypotenuse is hypotenuse over opposite. So this ratio 5 over 3 is the ratio of the hypotenuse over opposite. In this example, we assume that theta is an acute angle of a right triangle. And if theta is an acute angle of some right triangle, then cosecant of theta is, whose value is 5/3, must be equal to the ratio of the hypotenuse of the right triangle and the side opposite the acute angle theta. Using our notations in this right triangle, we denote the hypotenuse by small c, and the opposite side, suppose we take A as the angle theta, we denote the opposite side by small a. We denote the hypotenuse by small c, the opposite side by a. And therefore, the small letter b will be our adjacent side. Or you may do away with these notations. You simply write 5/3 equals hypotenuse over opposite. And this implies that our opposite side, the side opposite the angle theta, is 3. And the hypotenuse of the right triangle, of which theta is one of the two acute angles, is 5. And we find the side adjacent to theta. And we need to find the adjacent side to find the values of the other trigonometric functions of the angle theta. And to find this the side adjacent to theta, we apply the Pythagorean theorem, because the three sides of a right triangle satisfy the Pythagorean theorem. We now apply the Pythagorean theorem to find the adjacent side, or the side adjacent to the angle theta. By Pythagorean theorem, the square of the hypotenuse is equal to the sum of the squares of the two other sides. And with reference to the angle theta, the two other sides are the adjacent side and the opposite side. We are given the hypotenuse is 5. 5 square equals, it is the adjacent side that we want, equals the square of the adjacent side plus the square of the opposite, and we identify the opposite side as 3 plus 3 squared. And square of 5 is 25, equals the square of the adjacent side plus the square of 3 is 9. And we transpose 9 to the other side, and we are left with the square of the adjacent side at the other side of the equation. The square of the adjacent side equals 25. And positive 9 we transpose to the other side, we take the opposite side, we get negative 9. And the square of the adjacent side is 25 minus 9, 16. And we take the root of both sides, hence the adjacent side is 4. 4 units. The required is to find the other the values of the other trigonometric functions of theta. we are given that cosecant of theta is 5/3. We find the sine of theta. Sine is the ratio of the opposite to the hypotenuse. Opposite to the hypotenuse. And the opposite is 3, hypotenuse is 5. Or we are given cosecant of theta is 5/3, and cosecant is the reciprocal of sine. So the reciprocal of 5/3 is 3/5. And if you take the reciprocal of sine equal to the reciprocal of 3/5, we get cosecant of theta equals 5/3. Now, cosine of theta is the ratio of the adjacent to the hypotenuse. And we found the adjacent side for the hypotenuse is 5. Tangent of theta is the ratio of the opposite to the adjacent. We are given the opposite is 3, and we found the adjacent as 4. And we skip the reciprocal of sine theta, which is cosecant theta, because it's already given. The reciprocal of cosine theta is secant theta. It's the reciprocal of adjacent divided by hypotenuse. And secant theta is hypotenuse over adjacent, which is equal to the reciprocal of 4/5. Or hypotenuse is 5 and the adjacent is 4. 5/4. And cotangent theta is the reciprocal of tangent, the reciprocal of adjacent to the opposite side, which is equal to the reciprocal of 3/4 or 4/3. Adjacent is 4. And the opposite side is 3. These are the values of the other 5 trigonometric functions of theta. We consider another example. In triangle PQT, angle Q is 90 degrees. So this triangle with vertices PQT is a right triangle with the right angle at vertex Q equals 90 degrees. And we are given the tangent of T. Hence, if Q is a right angle, P and T are the two acute angles of this right triangle PQT. And we are given that the tangent of T is 1/2. Find the values of the trigonometric functions of P. The angle P. We can also find the other 5 trigonometric functions of angle T, but the required are the values of the trigonometric functions of the other acute angle P. And we first identify the sides, the opposite side, the adjacent side, and the hypotenuse of a right triangle PQT with reference to angle T. The figure or diagram will help us solve for the unknowns in the problem. So for this example, we draw the right triangle PQT, And the right angle is vertex Q, because we are given that angle Q equals 90 degrees. And this is 90 degrees as indicated by this square, small square. And one of these, the two acute angles are these angles. And you take one of them as P and the other will be T. I will take this as angle T. And the other will be angle P. We are given that the tangent of the acute angle P is 1 over 2. And we know that tangent of an acute angle is defined as the ratio of the opposite to the hypotenuse. And this implies 1 over 2 equals opposite over hypotenuse. This implies that the opposite side, the side opposite angle T is 1. The side opposite the acute angle T we denote by small letter t. And this implies the opposite side is 1. Numerator is opposite side. Numerator of this fraction is 1. Opposite side equals 1. So the value of this small t, the side opposite the angle t, is 1. And this implies that the hypotenuse is 2. The hypotenuse is the side opposite the right angle Q. The right angle is denoted by capital Q, thus we denote the side opposite the right angle Q by small letter q. And the hypotenuse is 2. Hence, the small q, the side opposite angle Q is 2 units. And we want to find the side adjacent to acute angle T, which is also the side opposite the acute angle P. Thus, we denote this side by small letter P. And we find the value of small p, the side adjacent to angle T, or the side opposite angle P, by Pythagorean theorem. Thus, we write by Pythagorean theorem Pythagorean theorem says the square of the hypotenuse. In our diagram, the hypotenuse is small q. The square of the hypotenuse is equal to the sum of the squares of the two other sides. The two other sides are t and small p. T squared plus p squared. And we substitute the given. Small q, the hypotenuse is 2. 2 squared equals small t is 1. 1 squared plus p squared. Thus, p squared equals, we transpose 1 squared to the other side. At the other side, we have 2 squared. And we transpose 1 squared to the other side. We take the opposite side. We get minus 1 squared. Or p squared equals, the square of 2 is 4. Minus the square of 1 is 1. Therefore, p squared is 3. Or we extract the root of both sides. Square root of p squared equals square root of 3. And we get p equals square root of 3. And that's the side adjacent to the acute angle P, or the side opposite the acute angle P. We now write square root of 3 in the diagram. Now we have identified the sides of this right triangle. We can now find the 6 trigonometric functions of the acute angle P. If we are considering the acute angle P, the opposite side will be square root of 3. This will be the opposite side. And the adjacent side will be 1 unit. What we are required are the values of the 6 trigonometric functions of angle P. Find the values of the trigonometric functions of angle P. So if you want the functions of angle P, you identify the side opposite angle P, it's square root of 3, and the side adjacent to angle P, P, or equals 1 unit. The hypotenuse will remain the same, 2 units, regardless of which acute angle you are considering. We start with the side of angle P. The sine of angle P is defined as the ratio of the opposite to the hypotenuse. The side opposite angle P is small p. Divide by the hypotenuse. The side opposite the right angle is small q. And substitute the lengths of these sides. Small p is square root of 3. And the hypotenuse q is 2. Now cosine of p is the ratio of the adjacent side to the hypotenuse. The side adjacent to angle P is small p. The hypotenuse is q. We substitute the values of P and Q. P is 1 unit and Q is 2. The third function, tangent of P, is the ratio of the opposite to the adjacent side. Opposite of angle P is small p, and adjacent to the acute angle P is small p. Substitute the values of P and T. Small p is square root of 3. And small t is 1. Or we simply write square root of 3. Tangent of angle P equals square root of 3. Now, the fourth trigonometric function is the reciprocal of sine, which is known as the cosecant. Reciprocal of sine P is cosecant of P. It's the reciprocal of opposite to the hypotenuse, which is equal to hypotenuse over opposite. And it's equal to the reciprocal of P over Q, or hypotenuse is Q, opposite the acute angle P is small p. Q is 2 over square root of 3. Now, in algebra, we usually remove the radical sign from the denominator. And the process to do that is what is known as rationalizing. So, to rationalize this is to remove the radical sign from the denominator by multiplying numerator and denominator by the root of 3. And if you do that, multiply numerator and denominator by the root of 3, this will simplify to 2 times square root of 3 over 3. By property of radical, square root of 3 times square root of 3 is 3. Hence, we have removed the radical sign from the denominator. So, the cosecant of angle P is 2 times square root of 3 over 3. Or you can write 2/3 times square root of 3. Next, reciprocal of cosine P is secant. The secant P equals the reciprocal of adjacent over the hypotenuse, or hypotenuse over adjacent. In our example, the hypotenuse is Q, and adjacent to acute angle P is what? P, small p. The hypotenuse is 2, small p is 1 or 2, which is the reciprocal of 1/2. And tangent P is, the reciprocal of tangent P is cotangent. Cotangent of P equals the reciprocal of opposite over adjacent. Adjacent over opposite. And adjacent to the acute angle P is T over opposite the acute angle P is small p. We substitute the values of T and P. T is 1 and P is square root of 3, which is the reciprocal of square root of 3, or reciprocal of square root of 3 over 1. These are the 6 trigonometric functions of the acute angle P. If you have questions about the lesson today, you ask your questions in the comment below. And do not forget to subscribe to my YouTube channel, Art Kalison. Thank you.